What's up everybody, DadTech TV here, and today we're continuing my journey to the eCPPT, finishing up the system security section. Alright guys, I'm back. Obviously I disappeared for almost 3 weeks, but I gotta tell you, I was on vacation and vacation was amazing. But now it's time to get back into my studying and time to update you guys on where I'm at. So I finished up the second half of the system security section. My feelings continue to be the same, is that there is a lot of overview of a lot of different subjects. It's a lot of items that you can then go deeper into later on if you really want to learn those subjects. To quote, I guess it's quoting, it's coming direct from their slides. They even tell you that they're giving you the knowledge to expand your understanding and become a successful pen tester, but they're not giving you the answer key. So they're introducing you to everything and then allowing you to kind of see where your career takes you, because you can focus on just one of these many pieces and be very successful in that area. The interesting part for me is thinking about how this is going to play out on the exam, because this first section that we've had so far doesn't really have a lot of lab or hands-on. It's a lot of just information you're taking in. While I was really happy with the PTS because there was a lot of hands-on, this kind of shies away from that so far and goes more into a regular exam that you would take or studying that you have to do for a certification. So I think that that's going to change in the next section. This first one though is a lot of reading, a lot of information, and it can burn you out a little bit if you try to just kind of bang it out. So as you can see right now, I'm back in a Linux box on Kali. That's not necessarily because we're working with Kali here, because like I said, there isn't a lot of labs with this information, but there are some small pieces and it does kind of suggest using Kali at this point. Alright, so following the system security section, the next module that I got into was shellcoding, which is module 4. So if we look here and I scroll down, you'll see we went through architecture fundamentals, assembly debuggers and tools, buffer overflow, and buffer overflow leads into shellcoding. Because shellcoding is the code that gets injected, the malicious code that you're injecting when you're exploiting a buffer overflow. So in this module, they talk a little bit about how to create shellcode and then how it gets executed. They talk a little bit about the EIP and the SEH. SEH, I believe, is new in this module. I don't know if we talked about it in the buffer overflow, but it's basically the exception handler. So you can force an exception by dividing by 0. The SEH is the handler that stores the address to jump to from there. So you can kind of exploit that and take advantage of it to execute your code. They talk about all the different types of shellcoding, local, remote, and then they also talk about some terms that you might have seen in the PTS or in Metasploit that maybe they didn't give a full explanation of, but that's different types of ways to connect. So they have the connect back, the bind shell, and socket reuse. So the interesting part with this is that they start talking about shellcoding and they immediately say, yes, there are a lot of tools out there to help you generate shellcode, but to get you to understand the fundamentals, they want you to manually do it and they walk you through that. So they start off with some rules. With a C language string function, you have to understand that these work until you hit a null or a 0. So when you're creating your shellcode, you have to make sure that you don't have a null or a 0 because it won't execute the rest of your code. So they talk about strategy on how, if you need to put a 0 in, how you go about doing that. So rather than just moving a 0 into a register or wherever you're putting it, you can do something like an XOR function. And we're talking assembly code again, where you can do XOR, EAX, which is good. Or you can do a subtraction function, where you basically move a number into a registry and then you subtract that same number. So now you're not moving 0 into it, even though you're getting 0 as the result when you do the subtraction. So after knowing some of the basic rules, they want to actually show you manually how to create the shellcode. For those that don't know what shellcode looks like, I did a quick Google search here, and I believe this is a good example where you have your /x and then bytecode. So in order to generate this manually, what we do is that we create a small assembly program. We compile it into an object, and then we basically decompile it. And when we decompile it, we take that bytecode and we prefix it with the /x, and that's where you get the code. So basically you're assembling your code and then you're decompiling it, which is pretty cool to kind of understand how, because I've seen a lot of people post screenshots of the shellcode that they're putting together. I've seen other snippets here and there. I never really saw how to create it on my own. So this was a really cool module to really get to see how to do that. One of the things to note here, especially if you're trying to exploit buffer overflows on a Windows box and trying to get code to execute there, you need to understand some of the system DLLs, kernel 32, user 32, shell 32, because within those DLLs, you have specific functions that you want to try and use. Ones that they talk about, the examples that they give is using the sleep function, because that's one of the easiest it looks like. And then from there, they also talk about message box. So basically your malicious code is just popping up a message box when it executes with whatever message you want in there. So the sleep function is within the kernel 32 DLL, and the message box is within the shell 32 DLL. So in order to find out where those are, their addresses, you then have to use the immunity debugger or the debugger of your choice to actually debug the DLL and then search for like the sleep function within there to see the address that it's currently at. So there's a little bit of extra work behind it rather than just writing code. You need to understand a little bit about the DLLs and a little bit about where those functions are currently on the machine. From there, they then talk about one specific tool that can generate shellcode on its own. That's the MSFVENOM from Metasploit framework Venom. So if we take a look at that, you can actually do MSFVENOM -- list payloads. And it takes a minute, but this is actually going to list all the payloads that they have there for you. You can look at all the options on it, and then you can actually also create custom shellcode too. So they walk through all that. So I thought this was a pretty good follow-up to the previous module of buffer overflow. And that's because this then kind of takes it to the next step to say, okay, here's how buffer overflow works. From there, you're going to run malicious code, and now it goes into here's how you kind of create that malicious code that you can then run when exploiting a buffer overflow. So I thought this was a really good module. Had a lot of information. I think that if you really wanted to learn how to create shellcode, you're going to have to go way more in depth with a different course or some different resources. And they actually provide some additional resources that you can look at to get more information on all of these subjects. The next module they jump into is the cryptography and password cracking. So I'm a big fan of cryptography. I've done some research on different subjects, but they really kind of look at a lot of different things that are underneath that cryptography umbrella. And then of course they go into a little bit on password cracking to understand how you crack and get around the cryptography. So once again, it covers a lot of broad information on a lot of subjects, but doesn't necessarily go really in depth on any of them. But that's good because to really get in depth on some of these would take a lot more time. So again, they start with a classification. They talk about symmetric versus public key. They even talk about history a little bit as Caesar cipher. But then it leads into classes of algorithms where they talk about block cipher, where you're handling everything in data blocks, versus stream cipher, where data is handled 1 byte at a time. And of course, they get right into ECB and CPC after that. ECB is electronic code book, and this is actually a deprecated method. So this is where each block is encrypted separately, and it's encrypted the same way each time. So that means if you have the same block, no matter where it is, it's always identical when it's encrypted. So you can kind of match those up eventually. Whereas with CBC, which is the cipher block chaining, each ciphertext block is derived from the previous block with an initialization vector for the first block. So that means you could have an identical block right next to each other, but when they get encoded, they'll actually be different because the second one is based off the first one. And if the first one is the actual first one, it's also based off of a initialization vector. So from there, they actually talk about hashing, and they talk about why you would hash instead of encrypt, for speed, because it goes faster, where encryption might use more CPU. Hashing is faster, but it's not necessarily as strong. After that, they move into PKI, public key infrastructure, which is PKI. And they talk about the certificates and certificate authorities. So for this, you're talking like SSL and things like that, where if you go to a web page, you'll see that it has the locked, it's like a locked page, so it's trusted and it is legit. So basically the cert says this is who you think it is on this web page, and there's a certificate authority that has validated that is a legit cert, and it's safe to communicate. And with SSL, it actually also encrypts the transmitted data. The one interesting point with that is that the browser must trust the certificate authority, and they make a point to mention that. From there, they talk about digital signatures, and then after that, they move into PGP. PGP is pretty good for privacy, and it's specific to email. A lot of people, when they were following Edward Snowden, maybe they heard about it for the first time at that point, but he talked a lot about PGP, and PGP seemed to become very popular for a lot of people in communicating through email at that point. So PGP uses private and public keys, and with PGP, it's associated with your email address. So basically, you have two keys where you keep your private key. You need to keep that one secure, but your public key you can share with other people. So you share that with your buddy, and your buddy uses that public key to actually encrypt a message to you. When you receive it, you then need your private key that only you have to decrypt it, and nobody else can decrypt that message without having that private key. So the public key is only for encrypting, where the private key is for decrypting. There's two standards for that, and there's Open PGP and the New PG. PGP actually puts together the ideas of symmetric key encryption, public key encryption, and hash functions, along with doing some text compression. So PGP is pretty cool. It's nice to see an overview of it, but again, you can get way more in depth if you start looking this subject up. The other cool thing about PGP is that you don't actually need to pay for it, whereas with a certificate authority and using PKI, you need to pay for that cert. After that, then they start talking about SSH. This is basically so that you can tunnel traffic through firewalls securely. And this is a really good one to understand and learn, especially if you want to access your home computer from work. Maybe you can set up a SSH server on your home computer, but make sure you look up how to do that correctly, because I have seen specifically on my computer that people just scan the internet constantly to see what ports are open. You use your standard SSH port. They know they know that you have SSH open, and they'll try to connect with standard usernames and passwords. So from what I've seen, they know a lot of people actually use Raspberry Pis now, and the people using Raspberry Pis that are focused on doing specific tasks may not be focused on security. So they're actually trying to connect as if it's a Raspberry Pi, using Pi as the username. But they use a lot of other ones like admin, administrator. I've seen so many just generic kind of usernames that they try to log in with whatever the generic password is for certain devices that use SSH regularly on the internet. But SSH gives you an encrypted tunnel. So when it goes through the firewall can't really see what the traffic is. So you're able to actually run different types of protocols over it. So you can do IM through it, you can mount hard drives through it, you can do RDP through it, you can do web through it. There's a whole bunch of different things. I think it's very powerful. Outside this course, they don't mention it in the course, but one thing that you might want to look into is Bitvise, BITVISE, which is a SSH server and SSH client that you can use to set up at home. After that, they start talking about their password cracking and attacks on cryptography or on, passwords. And of course, they initially go into brute force. So brute force is basically where you're just trying every combination from A to 99999, which they actually put in there. It'll work every time, eventually, if you have enough time to do it. After that, they talk about dictionary attacks. So basically, one of the problems with passwords, no matter what you do to secure them, is the user aspect. And users or people will use very bad passwords, and they will use passwords that a lot of people use. I remember reading a tweet on Twitter. Interesting. Anyway, I read a tweet, and a security professional was talking about a pen test that he was doing, and within 20 minutes, he was able to figure out what location they were in, because everybody used the same favorite like football team as their password. So it's quite interesting to see that people will regularly use the same types of passwords, whether it's their favorite sports team, whether it has to do with their birthday. And there's a lot of things. There's things of password as your password, generic things. So you need to watch out, and that's why dictionary attacks work well. So if you have a good list of generic passwords that many people use, you can then attack based on that dictionary. But it only works if that person's password, or the account that you're attacking, that password is in your dictionary. From there, they talk about rainbow tables, which are pretty cool. So a rainbow table is a table of plain text and ciphertext. So rather than saying, okay, I have a password that I want to try, and then it has to encrypt and become ciphertext to try and match up, you already have the ciphertext, so that you can try and just match the ciphertext to the encrypted password. And then if it matches, you can just say, okay, here's the plain text password. The problem with this is that not all of the rainbow tables are free, because these are very large tables and take time to actually generate. So that's the other thing, is that if you don't want to pay for them, you can then generate them yourselves, but you need a lot of disk space eventually and a lot of time to actually generate those. Then they talk about side channel attacks, which looks at physical implementations such as CPU cycles used during algorithms to produce important info that you can use against or to understand how it's working. They also talk about the birthday attack, which is pretty cool, because they talk about how it's based on the birthday paradox, where if there's 23 people in a room, 2 people have more than a 50% chance of having the same birthday. And they talk about how you take 23 and then you take one of the 23 and try to match it with the other 2. And if it doesn't match, then you drop that one. Then you take another one and try and match it with 21, and you keep going, and it makes 253 pairs. It says with 253 pairs at the end, you cross over that 50% chance of matching, which is pretty cool. After that, they talk a little bit about security pitfalls. So they talk about looking at the whole system, not just destroying plain text after use, about how they allow recovery of passwords and how you can exploit that. So you might not need to actually crack the password. You might be able to look at the whole system and kind of take advantage of some of the other aspects of it. We already talked about human error, which they talk about, where you basically just have a weak password, or those users are falling for phishing and social engineering scams. So that's always a problem. And then they finish off specifically with Windows hashing, and that's the SAM database and the system file, LM and NT hash. So if you guys have looked into trying to crack Windows passwords, this would be very familiar to you. Once you get into Windows 10, it's a little bit different. So they're talking about a little bit older systems. They go into specifically how LM works and how it's not secure and why. From there, they also talk about things like stealing the hash. So how do you get the hashes? Then they talk about offline access, so you can actually download it or bypass or even overwrite it. Then they talk about passing the hash, which is where you don't actually get the password, but because you have the hash, you can kind of use that hash to authenticate. It's called passing the hash. They talk about utilities to take advantage of that. And then they also talk about Metasploit and how Metasploit can take advantage of pass the hash. And then the last thing that they talk about is crack the hash, which is, using OFRAC and rainbow tables or John the Ripper and dictionary or brute force attacks. So this was a really good module to go over a lot of the different cryptography, along with how they actually crack those different pieces. So then at the end, they go into malware. And for anybody in the IT industry, you know that malware can be a headache along with phishing attempts. So this was quite an interesting module to kind of go into and read about everything. It stays true to overview of a large amount of topics again. It starts with listing all the types of malware, and that includes virus, Trojan horse, rootkit, bootkit, backdoor, adware, spyware, grayware, dialers, keyloggers, botnet, ransomware, data steal malware, and worms. They also talk about techniques used by malware. Most importantly, they talk about streams, hooking native APIs, and hooking IRPs. So they're really going into a lot of information where if you want to become a malware analyzer, tester to kind of understand. So when malware comes out, if you want to be the guy that kind of takes a copy of it and says, I want to figure out how this works and how to stop it, then this module gives you that overview. Other important topics they talk about are, I'm going to say this wrong, obfuscation, packers, polymorphism, and metamorphism. Funny side note is that as I was going through all this, I was pretty burnt from taking in all this information. And when they're talking about metamorphism, they talk about garbage insertion. And for all the guys that out there that have seen the movie Hackers, I just started laughing because I was thinking about the movie Hackers and the garbage file and kind of different scenes from that movie. So because I was taking in so much information at that point. But really good topics. I'm not going to get into them. If you guys want to learn these, then you guys need to take this course. And then from there, you need to kind of even go into more outside of the course, because these are very malware, and analyzing malware is a very big subject, and it's not easy to give an overview, and I think they did a great job here of giving an overview of it. So when analyzing and testing malware, they make sure to say, hey, you need to run this in a VM, which is a virtual machine. You don't want to run this on your regular machine, because obviously you're basically putting malware on there to see how it actually works. You want to make sure that's separate from your network, from any other connected machines. They then also talk about that malware can detect that it's running on a VM and act differently knowing that it's on a VM, or not do anything while it's on there, which makes it harder for people to analyze what it does. Which is kind of funny that, people out there writing malware, they also understand the techniques to kind of stop what they're doing. So it's kind of like a constant battle back and forth between those trying to stop it and those creating it. One of the last things that I just want to mention is that they also give sample programs. So they give you like a sample virus to kind of take a look at. And one of the other things they give you is a keylogger, which is pretty cool, but it's not, they don't give you one that you would really want to use. And when I say use, that's in a pen test. I'm not saying go use it to actually steal keystrokes from somebody, because obviously that's illegal. And that's probably also one of the reasons why they give you a keylogger that's not necessarily the best one to actually use. They do mention specific to keyloggers or anything else that if you want to use these during a pen test, make sure you have written permission from your customer, from that company, before you actually use it. You need written permission because it is illegal to use those. So at this point, I just want to say that I'm actually really glad that I'm through the first section, the system security section. I thought it was a lot of information without much hands-on. I thought it was really great information, but I was hoping it was be more like the PTS course, where right from the beginning, I mean, in the beginning they do kind of have information, but it's not an overload. This seemed like an overload on some of the subjects to me. Even though they're great subjects, I was hoping to jump right into some labs and everything, and I didn't feel that it had that. But I do feel like it's a good background of information. I'm still wondering how this is going to play out into the exam, if this information is really going to be on the exam, if there's going to be questions about it, because there's no real labs to actually say, okay, you're in this environment, you need to, create a shellcode. I mean, maybe we will have to, but I'm not sure. So it'll be interesting to see how it plays out in there. So I am ready to move on to the next section, which is network security. And I'm happy to see that the first 6 modules have labs, so I'm really happy about that. So thanks for listening. Go ahead and hit subscribe. I'm going to continue my journey to the eCPPT and keep putting up videos, so I will be back soon.